So, imagine this. A Nobel Prize-winning physicist just dropped a truth bomb that basically says, reality as you know it might not even exist the way you think it does. Your morning coffee, your dog wagging its tail, even you sitting there watching this video, all of it might be stitched together by a universe that's far stranger, glitchier, and more mind-bending than Hollywood could dream up. And the wildest part? The math checks out. Welcome back to the channel where curiosity doesn't just kill the cat, it launches it into orbit. Today we're diving into the strange new reality that Nobel laureates have uncovered. And trust me, once you hear this, you'll never look at the stars or your socks the same way again. Quick pause. If you love facts that make you the most interesting person at dinner parties, hit that like button. It helps this channel survive the YouTube black hole algorithm. All right, let's get cosmic. In 2022, the Nobel Prize in Physics went to 3 scientists, Alain Aspect, John Clauser, and Anton Zeilinger, for something that sounds harmless at first. Experiments with entangled photons. Cute, right? Except what they really did was prove, once and for all, that Einstein was wrong about one of the biggest assumptions of reality. See, Einstein called it spooky action at a distance. He hated the idea. But these Nobel winners showed that particles can be connected in ways that completely ignore space and time. You can separate them by miles, even light years, and boom, change one, and the other instantly changes too. No signals traveling, no delay. Just instant connection like the universe is running on some cosmic Wi-Fi we don't understand. Let's put that in human terms. Imagine you and your best friend both order pizza. You're in New York, they're in LA. You open your box, pepperoni. Instantly, their box in LA switches to pepperoni too. No delivery guy, no phone call, just boom. Cosmic pizza synchronization. That's quantum entanglement. And the Nobel Committee basically said, yep, this isn't science fiction anymore. It's real, tested, verified. Your universe is officially weirder than your uncle's conspiracy theories. But here's the kicker. This isn't just about tiny particles. If the building blocks of reality don't obey normal rules, then what does that say about the big picture? Your sense of time, cause and effect, the idea that you're making choices right now by your own free will, all of that might be an illusion. A very convincing illusion, sure, but still an illusion. If your brain just twitched a little good, that means you're awake. Go ahead and share this video with a friend who loves space facts, because trust me, they're gonna argue with you about this for hours. Here's where it gets spicy. For decades, physicists argued over whether the universe was fundamentally predictable. Einstein thought, nah, God doesn't play dice with the universe. But these experiments, they showed that not only is the universe rolling dice, it's doing it behind your back under the table with loaded dice you'll never even see. Translation? Reality is non-local and random at its core. That's a fancy way of saying the rules you thought were solid, like the speed of light being the fastest limit or objects existing in just one state at a time, are more like guidelines, very flexible guidelines. And here's where the strange new reality really hits home. This discovery opens doors to things like quantum teleportation, unbreakable communication systems, and maybe, just maybe, a way to understand why the universe exists at all. Yeah, I know, big leap, but hang tight, because in the next section, we're going to dig into just how bizarre quantum mechanics gets, and why Nobel Prize winners keep saying reality might be more of a cosmic simulation than a physical thing. So buckle up, grab your pizza box. Particles are about to start teleporting, and your definition of real is about to take a serious hit. And hey, don't even think about leaving. The deeper we go, the crazier it gets. Hit subscribe right now so you don't miss the moment where we break your brain in the most fun way possible. So we just learned that Nobel Prize-winning experiments proved the universe might be running on some kind of spooky Wi-Fi connection. But here's the thing, quantum physics doesn't stop at entanglement. Nope, that's just the tip of the cosmic iceberg. Once you peek under the surface, you start seeing a reality that makes the Matrix look like a boring PowerPoint presentation. Let's start with the idea of superposition. This is where particles don't just pick one state. They chill in multiple states at once, like some cosmic overachievers. An electron, for example, can spin up and spin down at the same time. It's like flipping a coin, and somehow it's both heads and tails until you look at it. Now, If that sounds confusing, it's because it is. But here's a more human way to get it. Imagine you're both at work and at home, binge-watching Netflix at the exact same moment. You only collapse into one version, employee of the month or couch potato, when your boss checks in. Until then, both are true. That's how the universe rolls. And this isn't just some weird chalkboard theory. It's been proven in labs again and again. One of the most famous tests is called the double-slit experiment. Physicists shoot tiny particles, like electrons, at a barrier with two slits. You'd expect them to behave like little bullets, right? One slit or the other. But nope, they behave like waves, creating interference patterns, as if each particle went through both slits at once. And here's where it gets creepy. The moment you try to observe which slit the particle actually goes through, the interference vanishes. Suddenly, the universe acts normal again. Translation: the universe basically says, "Oh, you're watching me? Fine, I'll behave." It's like catching your cat on the kitchen counter. When you're not looking, it's everywhere. The second you turn the lights on, boom, it's sitting innocently on the floor like nothing happened. If that just blew your mind a little, go ahead and smash that like button. It tells me you want more of these reality-bending stories, and it convinces the YouTube overlords that we're worth recommending. Here's the wild part. That experiment doesn't just apply to tiny particles. In theory, it could apply to you. Right now, there's a microscopic chance you're sitting in your chair and floating on a beach in Hawaii until observation collapses you into one reality. Sounds ridiculous, but the math says it's not impossible, just extremely, painfully unlikely. So technically, you are living multiple lives in parallel universes. You're welcome. Now let's push it even further. Entanglement plus superposition gives us one of the most insane technologies humans are building right now. Quantum teleportation. No, we're not talking about Star Trek beaming people onto spaceships just yet, but scientists have already teleported quantum information, like the state of a particle, over dozens of miles using entanglement. In 2017, researchers even teleported data from Earth to a satellite in orbit. That's right, teleportation has already left the planet. And while we're not about to teleport a burrito into your kitchen anytime soon, this tech is laying the foundation for a quantum internet, a communication network that's faster, more secure, and honestly, creepier than anything we've ever built. Think about it. A message could travel instantly across vast distances without any chance of being hacked, because any attempt to snoop would literally collapse the system. The universe itself acts like a bodyguard. And here's where space fans should perk up. If we can harness this, it could revolutionize communication with deep space missions. Forget waiting 20 minutes for a message from Mars. With entanglement, astronauts could phone home instantly, even across light years. It's like giving NASA a cosmic walkie-talkie that works anywhere in the universe. By the way, drop a comment below. If quantum teleportation ever becomes real for objects, what's the first thing you'd teleport? Personally, I'm torn between a taco and a brand new PlayStation. But here's the catch. Every step we take into quantum mechanics makes reality look less like stuff and more like information. Particles behave like data packets. Observers, like us, seem to play a role in shaping what's real. It's almost like the universe is more of a program than a place, and that's exactly why people, including some Nobel winners, are starting to whisper about the simulation hypothesis. Not as a joke, but as a serious possibility. What if the weird glitches we see in physics are just bugs in the code? Crazy thought, right? But hold on to that, because in part 3, we're leaving the tiny quantum world behind and zooming out into the big stuff. Black holes, warped space-time, and cosmic monsters that stretch reality to the breaking point. Trust me, you've never seen black holes explained like this. All right, so far we've dived into quantum weirdness, particles that can be in two places at once, spooky Wi-Fi connections across space, and even teleportation experiments. But now, let's shift gears. Because while quantum physics makes the small world bizarre, black holes and space-time make the big universe straight up terrifying. First off, black holes. The name sounds like a goth band from the 90s, but in reality, they're the most extreme objects in the cosmos. Imagine a star so massive that when it dies, gravity crushes it into a single point with infinite density. Infinite density. That's like compressing the entire Earth down to the size of a peanut. A peanut with the gravitational pull to eat the moon for breakfast. Black holes come with what's called an event horizon, basically the universe's version of do not enter tape. Cross that line, and not even light can escape. So technically, black holes aren't black, they're invisible. The only way we even know they're there is because of what happens to the stuff around them. Gas, stars, unlucky spaceships, whatever gets too close, spirals in at near light speed, heats up, and glows like the universe's brightest neon sign. It's like the world's deadliest bug zapper. Now here's where the Nobel Prize physics comes in again. Einstein's theory of relativity showed us that gravity isn't just a force, it's the bending of space-time itself. Mass tells space how to curve, and curved space tells matter how to move. That's why the Earth orbits the sun. It's literally rolling along the curve of space. And black holes, they're so heavy they don't just bend space-time, they rip it a new one. If you fell toward one, time itself would slow down for you compared to the outside universe. To a distant observer, it would look like you're frozen at the edge forever. Meanwhile, from your perspective, you'd fall straight in. Congratulations, you're now spaghetti. If this doesn't make you want to never go near a black hole, smash that like button. Because honestly, the only thing I want collapsing around me is a pizza crust. And here's where it gets even more insane. Black holes don't just sit still, they spin. And when they spin, they actually drag space-time around with them. This effect is called frame dragging, and it's been measured right here on Earth with satellites. Imagine space itself as a giant invisible sheet. A spinning black hole grabs that sheet and twists it into a whirlpool. If you got caught in it, the universe wouldn't just decide where you go. You'd have no choice but to swirl around like water going down a cosmic drain. But here's the wildest part. Black holes aren't just scary. They're physics laboratories. They push the laws of the universe to the limit. At their core, where matter is crushed into what's called a singularity, our best equations just break. Relativity says one thing, quantum mechanics says another, and both throw their hands up like, nope, I'm out. That's why some scientists say black holes might be the key to unlocking a unified theory of everything, a single framework that explains the big and the small, the cosmic and the quantum. And here's where our strange new reality comes back in. Because black holes don't just warp space, they warp information. Stephen Hawking discovered that black holes aren't completely black. They slowly leak radiation, which means over billions of years they can evaporate. But if that's true, then what happens to all the information that falls in? Physics says information can't be destroyed, but black holes look like they're shredding it. This is called the information paradox, and it's one of the biggest unsolved mysteries in science. If we crack it, we might discover that reality itself is made of information at its deepest level, just like in quantum mechanics. So yeah, black holes might literally be the universe's hard drives, except they occasionally delete files just to mess with us. Quick question for you, if you could safely orbit a black hole and see it up close, would you do it? Drop a yes or no in the comments. Personally, I'd pass. I've seen enough sci-fi movies to know how that ends. But here's the kicker. Black holes aren't rare. Our own Milky Way galaxy has one at the center, a monster about 4 million times the mass of the sun, and galaxies across the universe. Almost all of them have supermassive black holes anchoring their cores. Some are billions of times the sun's mass, eating stars like tic-tacs. So the very structure of the universe, the galaxies, the clusters, the web of cosmic filaments, all of it might be shaped by these invisible monsters. Space itself could be built on top of the strangest engines in existence. And just when you think that's as weird as it gets, enter dark matter and dark energy. These aren't just buzzwords. They're signs that 95% of the universe is made of something we literally can't see, or touch, or fully explain. So we've survived quantum mechanics and black holes. But now it's time to face something even stranger. The fact that most of the universe, the stuff literally holding everything together, is invisible. Scientists call it dark matter and dark energy. And if that sounds mysterious, it's because it is. These aren't fringe ideas. They're mainstream physics, backed by decades of evidence. And they tell us that 95% of the cosmos is missing from the picture. Let's start with dark matter. Back in the 1930s, astronomer Fritz Zwicky noticed galaxies were spinning way too fast. By all logic, they should have torn themselves apart like a carnival ride with bad bolts, but they didn't. The only explanation? There had to be an invisible glue holding them together, something with gravity but no light. That something became known as dark matter. Fast forward to today, and we know galaxies, clusters, even the giant web-like structure of the universe itself, all of it depends on this unseen mass. Without it, stars wouldn't cluster, galaxies wouldn't form, and you and I wouldn't exist. Here's the spooky part. Dark matter makes up about 27% of the universe. Regular matter, you, your phone, tacos, puppies, that's only about 5%. The universe's VIP section is made of something we still can't detect directly. But if dark matter is the glue, dark energy is the opposite. It's the cosmic repellent. In the late 1990s, astronomers measuring distant supernova found that the universe isn't just expanding, it's speeding up, like someone hit the cosmic gas pedal. This was shocking. Everyone thought gravity should slow things down over time, but instead, the expansion is accelerating. The only explanation? Some mysterious dark energy is pushing space itself apart. And here's the kicker. Dark energy makes up about 68% of the universe. So yeah, add it up. 27% dark matter, 68% dark energy. That's 95% of everything, which means all the stars, planets, and galaxies we actually see, that's just cosmic crumbs. If that stat blew your mind, drop a 95% in the comments. It'll confuse people scrolling by and make them click this video just to figure out what's going on. Now you're probably asking, how do we even study something we can't see? Great question. Scientists are running wild experiments underground, underwater, and even in space trying to detect dark matter particles. Some think it's made of exotic particles like WIMPs, weakly interacting massive particles. Others suggest axions, sterile neutrinos, or even something entirely new. Here's a fun one. Detectors buried deep in mines, shielded from cosmic rays, waiting for the tiniest blip of dark matter interacting with normal matter. So far, nothing confirmed, just tantalizing hints. It's like fishing in the dark with no bait, but knowing there's a giant school of fish out there somewhere. And dark energy? Even trickier. It might be a property of space itself, like a built-in pressure, or it could be a sign that our understanding of gravity is incomplete. Either way, it's rewriting the biggest story of all, how the universe evolves. And here's where it ties back to our Nobel Prize theme. The more we learn, the more reality looks like it's driven by forces we can't see, governed by rules that break common sense. First, entanglement showed us that particles are mysteriously linked. Then black holes revealed space-time can rip and warp. Now dark matter and dark energy remind us that what we see is barely the surface. It's like discovering your house is floating on an ocean you didn't even know existed, and that ocean is controlling everything. And if you're still watching at this point, congrats. You're officially part of the 5% who actually get the universe. Do me a favor. Share this video with a friend and see if they can handle it without their brain melting. So where does that leave us? We've got particles that defy logic, black holes that rip space apart, and invisible forces running the show. Which brings us to the big question. What does it mean for us? Why does any of this matter? That's exactly where we're heading in the final section. We'll talk about what this strange new reality means for the future of science, and why it might completely change how we see our place in the cosmos. So don't go anywhere. The outro isn't just a wrap-up, it's the part that'll leave you staring at the ceiling tonight, wondering what's real. So here's where we land. We've traveled from the ghostly world of entangled particles to the monsters of black holes, and out into the invisible 95% of the universe. Along the way, one thing has become crystal clear. The universe doesn't care about playing by our rules. Reality is stranger, deeper, and way more mysterious than anything we grew up learning in school. Think about it. Every breath you take, every star you see in the night sky, every text message you send, it's all riding on top of a hidden framework of forces and particles we can't see. You're literally living in a universe where the visible world is just the tip of the iceberg, while the true machinery hums invisibly below the surface. That's not science fiction. That's Nobel-winning, lab-tested science. And honestly, that should blow your mind a little. Because if reality can be this weird, then maybe we should all be a bit more humble about what we think we know. It's like the universe looked us straight in the eye and said, "You've only unlocked the tutorial level. Wait until you see the boss fight." If this journey left you buzzing with curiosity, hit that like button. Not just for me. Do it to confuse the algorithm into recommending more science instead of cat videos. Actually, who am I kidding? Watch the cat videos too. Here's the big takeaway. Every time scientists push the boundaries, the universe responds with a bigger, stranger mystery. And that's the beauty of it. We don't live in a boring, clockwork cosmos. We live in a reality that challenges us, teases us, and dares us to keep asking questions. So whether it's quantum entanglement, black holes, or the invisible hand of dark energy, remember this: the universe isn't just out there. It's inside you, around you, shaping every second of your life in ways you can't even see. And if that doesn't inspire awe, I don't know what will. So share this video with a friend. Start an argument. Spark a late-night conversation. Because the more we talk about this stuff, the closer we get to really understanding the strange new reality we all share. The universe has broken its silence. The question now is, are we ready to listen?